Hello everyone, welcome to the eighth lecture of this Python beginner course. So today we are going to deal with if, elif, and else. So these are conditions that are being used for operations. This is basically used when conditions are used for checking and used in operations. So here, this is the video 8. So this is going to be our roadmap for this lecture. We're going to start with if. As you know, in grammar also, in normal, in our normal day-to-day language like English, this means, or if this is this, this is that. So if is a type of checking, a checkpoint to see a type of standard it needs to meet. So if is a word that is meant to compare something for a given standard or a given output or a given data or value. That's the same thing that happens here. If is the same, and else is basically the same as our human language in which it stands, because else basically says, if not this, what else do we have? It denotes a backup option type of thing. So when if fails, we go to else. When if fails, we're going, what is the other option we have? Okay, when if condition is failed. So if something that we are comparing with or doing something, uh, if didn't match, so if didn't meet our desired outcome. So what else? What is the backup we have? That's when else is used to go. So the third one will be elif. Elif is used to denote whatever that comes inside if and else. If you when you go by Python code blocks, if it's a block, else is a block. So even if you want another conditions in between, we use elif. We'll come back to that in detail. And we have nested if. Nested, just like in our nature, what does a nest mean? Nest is something that sits inside of something or something that is cozy and so surrounded by everything, right? So when and if or anything is under some inside something else or inside another loop or if another loop or something like that, that's when it is known as nested. So when an if clause is under another if clause, it's called a nested if. We can have nested if else and stuff like that also. We also will learn about logical operators, which I have not learned till now, and how they link with if else, elif, etc., etc. And we will also do exercises. So we also do exercises. We will do multiple codes to see how it goes and how it isn't, and what are the codes, what are the questions, and we'll also have a mini challenge, which is our main part of our course. So, shall we begin, people? Friends, the roadmap is one, just like I explained before, it's going to be used for decision making. So, we are going to learn how is a decision made in computing. We're going to learn about if. We're going to learn about indentation. What is indentation? Indentation is nothing but space. So what is indentation? Else, elif, nested if, like I told you. When an if is inside an if clause, it says nested if. We will learn to debug. We will do 5 exercises, and we'll also do a mini challenge. So why decisions? Coming back to the first topic in this is to why decisions. Programs react very differently based on conditions. So when does the program learn how to do things? That's when we give it conditions, when we give constraints, when it gives conditions. That's when program is applicable in real life. Because in real life, not only one single design happens. In real life, there are multiple aspects that need to be counted and multiple possibilities that need to be accounted. So when you do all that, we have to see about decisions. So what happens? What is the decision the program makes when one thing happens and another action happens, or when that action doesn't happen? What is the decision it should do to counteract that, or something goes wrong? What is the decision it should do something else? This is not the input I was expecting. If the computer was not expecting the input that I was giving, should be the decision it should take? Stuff like this. That's why humans are very important when it comes to programming. because we are the ones who take the decisions, and we use these programming lines and codes and blocks to to put the decisions inside the programming so that the whole program is adapted to a situation it's going to face. So basically, this is a precursor to what the program is going to face in real life. Hence, we do use if else and elif, and more things in the future, which is loops also. We use these to track the decisions based on conditions their program is to work on. Is going to work on, is going to face. For example, if you take an example of age, if we will ask an age input, but for the program to function, the age should be more than 18 or equal to or more than 18. So when the input is given as 15, for example, or under 18 any number, the program should do something else, or the program should take a decision to not let you enter or log in, etc. if you are under 18, because the program demands you to be 18 or more age years of age. So that's why decision really matters in programming, and not just in Python, but all languages out there. So the second topic, which is where we actually going to start this lecture, the main part of this lecture starts is if statement. If statement is to run code if condition is true. Run code if condition is true. If is like a checking bar. As I told you, if like as I explained before, as I explained before, if is used as a breaking point for the computer, for the program. Check the condition above. We check the value above. We check the class above. For example, if you had, just like we did an example of age, if age is less than 18, it would not let you log in. So 18 is the benchmark. And it forces the program to check if the condition 18 is met or not. In the case it's not met, it will not let you log in. So that's why run condition, the whatever else that continues after if will only run if the if clause is satisfied. If your age is 18 or above 18, only you will be able to log in and do other stuff that program is programmed. But in the case that you are under 15, you are not 18 or over 18, so the program will end there for you. It will not let you log in. So that's the reason why if is such an important part, because if stops the program in that place, in the if clause, if the condition is not true, to continue for the account for not an abrupt stop, we have else conditions. So now before this, I want you to understand intended blocks also. Intended blocks are nothing but space. An intended block is four space bars or four space keys or one tab key. One tab key is equal to four space bars. Even though you are not supposed to use both of them together, you're only supposed to use any one of them together, because in the case that you use both, you're going to get a tab space error. You're not supposed to use both of them together. So you either use a single tab or you use four times space. So this is a common syntax for an if clause or an if code block. I'll show you in I'll show you in our VS Code. So we are going to make a Python program which takes age as an input. We are going to compare with an if block. as I said before, if we have used if clause, and here if I have applied I have given it uh, for age input, I have given 15. 15 is less than 18, hence it won't run because we don't have an else clause we didn't say to the computer to say, hey, in the case that you are under 18, do this instead. We have not said that. That's why elif and else comes in. We are yet to learn that. Yeah, I'm just going to show you if and explain the code. In the case that we are 18, we will say welcome to program because here, once again, last lecture revision, we used greater than or equal to function here, equal to operator here. So we have to understand that. That's why when I gave the function, when I gave the age as 18, it gave you welcome to program like intended. Now I'll explain you the code. Here, in the first line, we have taken the input of age, which is nothing else. We are using it from last two lectures, so it must be sorted. The second line is where the if clause starts. The first we use if. Capital IF. In Boolean, we start with not capital. I'm sorry, not capital. In Boolean, we start with capital, but here we start with small I. If, and then we put the clause. Then we put the benchmark. Then we say, hey, if this is true, go to next step. If not, we go to the else clause or elif clause. In this case, we don't have it, but after if is where you say what is the clause, what is the benchmark, what it needs the input or anything of that sort needs to be compared with. You have to say that including the comparison vector. Here, the age is the comparison variable. I have used age and told them, hey, if age is greater or equal to 18, and before going to the next line of code, we have to put a column. And then when we press enter, if you don't have autocorrect in your code, it will come like this. Here, this is wrong. This is where intended space comes in. So basically, we have to put a tab, a space worth of a tab, or we have to put a space of four spaces. One, two, three, four. Four spaces or a tab. Four spaces or a tab. But most importantly, it is much easier to use a tab. So many of people, majority of everyone will use a tab, not space. Four spaces if you're using space. At the same time, do not use space and tab at the same time. You are not supposed to use it. You are only supposed to use any one of it. I hope you understand the code. This is the framework. This is the variable, or you can put a variable, or you can have an input of a variable. You have the if, the main keyword here. You have vector. You have the comparison block to which you're being compared. The if the verb input or something like that is going to be compared. Then you put colon, you put a colon. You press enter. You press tab key. Majority times it's not, most of the times it's not necessary. It will indent itself equally, not equally, automatically. So majority times you are not supposed to indent it because it's automatically indented. But in the case that you are indented, you have to press a tab key from the star from just below if beneath I of if press a tab key. That's the space that you have to live. This space is called intended block or intended space. Going to indentation. Python uses spaces. Not just Python, every other programming language, even if it's C, C++, Java, everything uses indentation. So intended space is used for everything, not just Python. If you have a programming language, majority of them do use the intended block or intended space. Python uses intended space also because it's like programming language like everything else, but much better. Uh, The space that we live, which is one tab worth, just beneath I, where it starts is just beneath I, is known as an indented block or indentation. You are not supposed to use space and tab at the same time. This space is either one tab or four spaces, space bar space. Second is false condition. As you saw, when I actually executed 15 first, nothing happened. Nothing executes. With an if, only an if clause, and if it gives false condition, nothing is executed. The program ends there. You don't get the actual result at the same time. Yeah, I'll show you. We have demonstrated it, but I'll show it again. Run it again. This is the wrong input. Nothing executes. See, what is the final execution that needs to be done in our code? Which is, sorry about that, welcome to program, which is welcome to program. But here that is not executed because the condition that follows if is not satisfied. Because it's not satisfied, if clause is not satisfied, because of that, this will not be printed. Hence, we go to user. Just like we did before, you can always use age as an input or like the like the before examples that we saw, you can already have a variable with the age. Here, they have done the same thing. Age is an int input. We have asked for age. And if condition says that if age is greater or is equal to 18, we have to print it's an adult. It's adult. Ask age, then decide. This is a program. This has a little bit of a difference. I want you to all to run it. In the case you are not able to run it, we will do it together. So your time actually starts now. I want you all to give the input as number 15 also. Alright guys, time is up. It's time to check. We have taken it and we have to print. I have a framework here, so I'm not gonna take some time. Sorry. Hello. So I'll just on this it's asking to enter your age. I am 20 years old, so I'm gonna press 20. Here you go. I am an adult. It showed me as an adult. Now we are coming to the second part, which is else. Else runs when if is false. As we saw with if, when a false condition is happened, when a false condition is executed, nothing executes after the if when something else is not given. If the code only contains if block, nothing else is printed after the if condition. Hence, we use else for a different backup or something. We always need backups or always need multiple options to understand reality because reality is not a single vector or single dimensional. The reality you live in has many other vectors, many other decision factors, a lot of things that could go right, a lot of things that could go wrong, a lot of different scenarios that could play out in minute detail changes differently. That's why even we have theories like multiverse, where a single change influences a whole new universe. Like you all have to account for all of this while using a program. What all the faults that can happen? Because you know how to use it. I know how to use it. A third person might not know how to use it. So you want to account for all the ways how every single person in this world will use the software and account for all the different ways the software is going to be used. And hence you need multiple backup options and options to divert the traffic or divert the way people use. So people, for example, in the age checking software, many said age is 18. It will print adult. For the people that are not adult, you say, for example, 50. They gave input as 15, for example. If you only use each block, nothing executes. What does that mean? That person doesn't know. A person without computer, without the knowledge that we wrote only a if code, will think that the computer is broken. The code is broken, bro. They will think like that, right, guys? So we have to show them what is the next dynamic, what is the next process. Oh, hey, you are not 18. What are you? You are a minor. We have to see we have to show them that you are a minor. So that's where, which is to divert the traffic to show a different result for a fail clause in an if clause. That's where we use else, not just if. That's where we use else in Python programming. And here we will run an example. As you can see here, for the if clause age is greater than or equal to 18, we did print adult. This is what we did already today. This is what we did right now. Right? So now, in the case that a person enters 15, we saw that if the program just doesn't execute, it doesn't give out anything else. We need the else function. And here in else, meaning that if this doesn't go right, what else is the option? Here, that is option. Else plays as a backup option or to place or where the code goes to execute. So when the if condition fails or the if condition is not met, if condition goes false. Here, this is else part. Else part says that else if age is not 18 or greater, you have to print minor. Else some condition says that you have to print minor. This is why else is used. Else is used as a backup option, not just backup option, but an alternate option for if fails. You'll see this example. Where does else start? Else needs to start below the if. If and else and elif are all part of the same lecture. That's why we are learning all of these three in a single lecture. All three are pretty similar, are simply are treated by the same category in Python. Hence, we need to understand the fact that else will come beneath if, directly beneath if. It doesn't, it should not go anywhere else. And that's why we have to give a condition. In the case that else is given as the last condition, else is the last place where the execution goes. Here, else, you only print something. Else is the last place where you print something. Else is not a place where you give a condition because else is treated as the last resort. This is the last way a person will use this program. This is basically it. You have two options. If the first option is not right, you only have a single option left. So there is not going to be any clause or something in else. You cannot put a clause in else. Else, there is not going to be any clause. So else, you're just going to type else just beneath the intended block of if or directly beneath else. You're going to use the print function to print, for example, minus. Because why does else doesn't have any sort of a demand? Because if has a demand that age needs to be greater or equal to 18, but else cannot have. Because here if and else together is treated as two option questions. So if you have a question with only two options, you have either right or wrong. If one is proven as wrong, you have no other option to go to other than just else. So you only have one option to choose, and else doesn't always have any sort of a demand. Hence, we are not putting any demand in else. Hence, we are forced to print minor here. Why guys, that's what else is used. So it only runs when else only runs when if is false. So just like as I explained before, when you have a question when you have a demand. If it goes wrong, there's only two options. If one goes wrong, there's only the second option, which you will have to choose no matter what happens, right? So it doesn't need any sort of what do you call it? Any sort of stuff. So you have to use that. So now we are going to go to LF. LF is when you do that two choice question into a multiple choice question. Just like I explained before, the reality is not only reality cannot be contained in one if clause. Reality can actually cannot be contained into an L if and an else clause also. It might have a lot of choices. It should have a lot of choices, and so is programming. A programming can be a program can be used in multiple ways, in a lot of ways. And for you to on all of that, you cannot just do it with just an if and else clause. You have to have multiple choices, and that's where if, elif, and else comes in. You can have multiple elifs, by the way. So if is one way, if is a one choice. For example, elif can be n number of choices, and then at the end. So when you have elif, the whole choice block of code, which is if and if else, can have an if, which is mandatory. When you need a choice if it's mandatory, it will have one elif or multiple elif. It can be n number of elif. Depends upon how much the number of ways your program can be used is adapted for. And at the end, to top it all off, when you have every single other choices as wrong or is not met, you have a final choice, which is else. Else is always the final choice, even in a code only containing if and else. Else is the final choice. When a code with if else, else is the final choice. If is the starting choice. Elif is every other choices that comes in between both of these. Elif can be n number of choices. You can have n number of elifs. Elif depends upon the number of choices, the ways your program can be used, the input that a program can receive. LF basically depends upon that. LF is all the dynamics in which the your program is going to be used. For example, an LF code is given here for marks is equal to 18. So we are talking about marks. For example, just you take the grading system. If you have a grading system with A, B, C, for a given marks which is greater or is equal to 90, you are gonna award the person with A. And then you have another one. You cannot just go with, you can, if it's just, for example, the one with marks, if it's just pass or fail, you can go with if and else. If you just need pass and you don't need to show that person you're a fail, which is not a complete program, you can only use if. But when you want to grade a person with the different type of grade he achieved in the scale of A, B, C, like those, you need multiple LFs else if elif else's. So because here we are just gonna to explain it easily. Here we are just going to count it with an ABC system. So here for marks 80, we have the grading system, the comparison system or the choice system as if the marks that is given is greater or equal to 90, they're going to award the person A. If the marks is greater or equal to 75, we are going to award the person B. And if he is less than 75, because if these two things, if these two are false, there's only one option. You don't have to explain it. If even if it's not equal to or greater than 70, you don't have to explain it here that it needs to be less than 75. You don't have to, because if it's not greater or equal to 75, you know that it will be less than 75. Here, hence the last option is whatever. See, it's going to be less than 75. You know, because the first one, the elif one is having a greater or equal to 75. You know that if that's not the thing, you know it's going to be C. You know it is going to be less than 75. So in the else clause, which is the final option, you cannot, everything else faces, you end up in else. Else. There's nothing else. You have to choose else when everything else before take. faces. So because when it is ultimate option when everything else faces, you don't have to put or you cannot put a condition there. Hence, else always doesn't have a condition. For example, here we are going to use this else code. Let's use it. We are gonna go in this code. We are gonna do something a little bit different. We are gonna take it as integer input. We're gonna run the code. People interrupt. We are going to have to close this terminal. We're gonna run it again, guys. Enter your mark. I'm a straight student, so I'm gonna put 90. And the comma came out to be A. So in the case, but we will also check the derivative check, which is else. So if I put 65, gonna get C. C is the last option. It doesn't matter if it's 74. It doesn't matter if it is 1 or 0. You are the first two conditions have failed. You only have one condition to go because the last condition which is else, and else doesn't mean anything because else is the last condition. You have three choices. If the two choices, you cannot choose the two choices. You have to choose one choice, and you cannot choose two choices. You have only one choice that's left, and regardless of whatever, however everything is, you will choose that. Yes, that's what happens here. But you can have two LF too. You can have n number of LF. So we are going to add one more LF here. LF mark greater than or equal to 60. We are going to print mm, C plus the program. And my marks. My mark is 60. C plus, I got 60 plus. So you see, as I said, we can have multiple LF. LF is give you multiple choices of multiple blocks of choice. You can include multiple choices. That's why you have an LF block. The base skeleton of if, elif, and else is same. You have the first keyword. If it's elif or if you have the condition, you put a colon, you press enter. If it's if auto correction is there, you will already be indented. In the case you're not, you have to press the tab key so that you're indented. You do the print or whatever that needs to be done. Then you go out of it. Go down just beneath the if or elif and write the next elif or else and continue just like that. So this is LF, and here LF, once again recap of LF. This is to give you multiple choices when if and else is not enough. The whole world works on multiple choices, you need multiple choices. There are multiple ways the program can be used, hence LF becomes very necessary. If and else, LF lies between if and else, and you can have n number of LFs based upon the way the program is used. You can have multiple dimensions and hence multiple LFs, multiple choices, etc. And else is the last choice. You have no other choice. So else will be always be used when everything else before it fails. Hence else doesn't need any sort of condition to compare itself. It doesn't need a demand, whereas everything else, even if starting from if it needs. demand compare. For example, we have a small program, a program question, which is about grading program. So I want you to practice. I want you, I'll explain the question. I want you to take the input of marks as marks. If it is the marks is an integer input of marks, if it is greater than or equal to 90, I want you to print A. If it's greater than or equal to 75, I want you to print B. If it's greater than or equal to 50, I want you to print C. And if it's not 50 or if it's less than 50, I want you to print B. The code is not completely written here, hence I want you to work your brain. Your time starts now. Not looking at the code, I will tell you the code that you have to write again. I want marks as input from the user in integer form. I want if the marks are greater than or equal to 90, I want it as A. If greater than or equal to 75, I want it as B. Greater than or equal to 50, I want it as C. And else anything will be termed as D. Guys, I guess it's enough time for the practice program. Now we are going to the next. Now we will do the program ourselves. Yeah, we just have to add one more thing here. We've already done it, right? We've already done it. So I don't think we have to run it again, but we'll just run it again to see if we can see. Alright, guys. Now we are going to the next part, which is next topic, which is nested if. Nested if is an if inside an if. Okay, we have an if which gives a demand which will go and the execution for that is another if. So this is basically when you have to satisfy two demands. This is basically when you have to satisfy two demands with a single clause. If only satisfy one single command, one single demand. If a nested if is when it needs to pass two criteria. So first criteria says, okay, this is the first criteria. Now you might not only have one criteria, you have two criteria. So what is the second criteria? And nested if will have a second criteria inside of it, which will say, hey, if the student is, for example, 18 and he is eligible to drive, then give him the driving license, for example, something like that. So here in this scenario, as I said before, there's still two demands. Person should be 18 or older, and the person should know driving. So you cannot just say the person should above 18, 18 or above. That's one choice. Then you cannot put a NF and say if he should know driving. That's two choices. You don't have two choices. You have two demands. So you need a choice containing two demands. That's when a nested if happens. That's when a nested if is used. So here is an example. For example, an entrance exam. For that, your eligibility is you should be greater or equal to your age should be greater or equal to 18, and you should be a citizen of India, for example. And if citizen, you print eligible. All right. So this is what happens. This is a code example. We will run the code. Age is equal to in, input. and the age, and we'll also see. I'm going to use an advanced topic here. We are just going to execute it. For example, if we have a new variable citizen, and if the citizen is equal to citizen is input, array citizen, right? Now we have age greater than or equal to 18. Now we have a second. So if first demand is you should be greater than your age should be greater than or equal to 18. So the next demand is that you should be if you should be what do we call it, a citizen. So if we're gonna do another if. So if which is after indentation, you the nested if happens after indentation. So if uh citizen, we are going to compare it equal to yes. We have another nesting eligible. So we're gonna run the code. I'll just terminate this. I'll run the code again. Age, my age is 18. Are you citizen? I am a citizen. Oh, okay. One single problem. Right, let's fix to run it again. My age is 20. I am a citizen. Just clear this window so that it's much more clear for you to see. So there's not a problem. So my age is 20. I am a citizen, so I'm going to type yes. I'm eligible. So this is not an advanced topic, even though this was not in my mind, but we learned that a single uh, equal to sign is for assigning a value, and equal to sign is used for, what do you call it? It is used for, yeah, it is used for, what do you call it, man? It is used to comparison. It is used for comparison. So here it is comparing that if citizen, the value of citizen is yes or not. And here in the case that, in my case, it is yes. So it will run, for example, if it's no, it remains in, for example, if I no. The second demand, which is, I'm saying I'm not a citizen, it will say, are you a citizen? No, it stops there. Why it stops there? Nothing else is two X's. There is no else left. So if I want that to do, if I want that to exist, I will need to put an else clause. Where do we put an else clause? Not here, not under the second if. Else should be out in the first. If the two are not met, we have to put it in the. You can put the else anywhere, depends upon what you need. In else not eligible, print else to not eligible. You have to put two else's, print not eligible. So that's one thing. That's part of saying it. So that's everything about nested if. Now we are going to logical operators and or. So here we have, compare logical operators like and or are used to compare our demands or to join the demands. For example, we used and again, we used and before, right? We used and, we learned about and will, if using just a print function, and will give a Boolean value, and will only give a Boolean value true when both the conditions are true, and will give only false when both of the or and will give a false when even a single condition is not met. A single condition is false, it will give false. And demands both the conditions to be true for it to be true, for it to print true. And or on other hand, only needs a single condition to be true to print true. Whereas it needs both the conditions to be false for it to print false. We can use logical operators and or and then or we studied in last lecture. We use this in if in our if clause and if clauses, if else clauses basically. So for example, if we have to compare an age range, we use that if age greater than or equal to 80 and age greater than or equal to 60, print eligible. Here we don't have two demands, we have one demand. So we have to satisfy both the demands. We cannot just satisfy one demand. We have to satisfy both the demands. That's why we use and here. For example, we will run the code. Age as an input. Run the code. I'll post this demo so that it is for easy for you all to understand and else. Enter my age. My 20. I am eligible. So here, if I put 65, I will run the code again. If I am putting 66, it will not give anything because it will not execute anything because we are not given it an else clause. See, here we are using logical operator to for forcing if to only print when both the conditions, both the demands are met, or condition for only one single demand to be met, uh, and condition for both of them are met. For example, if we put or here. This is actually pretty dumb, I would say, because if it's or the first one is not, the second one is not, but so and even if you type 70, it will print eligible. So the second one is really not met. First one is type 70, it will print eligible. So see, or only needs one item to be one single, let's just say, clause to be finished. So here, even though the it says should be less than 66, uh, it is not gonna agree to it because it's saying or only needs one single demand to be filled. And here I satisfy the first demand and hence I want to be printed eligible. So this is the logical operator that is used in if else function. We are going to use a password example. Before that, I want you all to copy this code down. It will only take some time. I will give you some time to copy this code down to try it yourself. Alright guys, it must be enough. Now we are going to another example for this, which is password example. We are going to compare strings with this. Just like how we did compare with, we did an example where I compared the value of variable citizen. And there, for comparison, we use uh, two times the equal to sign. Two equal to signs means comparison, not assigning. A single one means assigning. So we are here to compare strings. So basically, we are here checking for if the password is correct or not. So we have password input as password. So if password is taken as input, it can be a string. So on it says that password comparison, if the password is lowercase Python, print correct, else it's print wrong. So this is the code. I want you all to try this out yourself. Then if you're not able to do it, we'll do it together. And your time starts now. is the like the example that we did on the citizen where I did it. The citizen one code was actually very easy. It was actually wrong. I intentionally put it wrong because here there the citizen was not declared. So I had to declare the citizen and I had to make sure how it works. That's the same thing in this one. So I want you all to try it yourself. Guys, time's up. It's time for us to touch. So the first one is to take PWD as input. We are gonna have an if clause, which is gonna be comparing. I'm gonna use capital Python here. Then welcome. Else, because there's nothing else is the last option. You don't need to put anything. You don't have to put any clause there, any demands, nothing like that. Try again. We'll run the code. You know what? I'll run this. New terminal. Password Python. My purpose is putting a wrong password. We'll say try again. We'll try with the new password. With the correct password, it says welcome. So this is the code. Hope you all understood the code. This is basically what we did. So here the comparison is used. We are for the people who forgot. This is the comparison recap. Uh, the two times equal to signs means compare. An exclamatory marks and a single equal to means not equal to. This is greater than. This is less than. This is greater than or equal to sign. This is less than or equal to sign. This is the comparison recap. So I want you all to really recap this. Think about the last lecture. This is where we studied the last lecture. This is what we studied in the last lecture. So I hope you have learned it. Let's go to the next section, which is common errors. So the first most common error that we see in if clause is missing the semicolon. You might have seen me also missing colon a couple of times here because it will cause a problem. Because if you see, this is a code with an if clause, right? So, like that. So in the case that we don't have a semicolon, you'll see what error it gives. It gives a syntax error. It says that we Python expected a colon, which we don't put here because we didn't put here. The code will not run. This is the syntax. So when a syntax goes wrong because it is colon, it will show you that it's not working. But when we put the syntax again, it starts working. Code is right. The syntax is right. So here I go. It works. So the second biggest error that we see is wrong indentation because that's why we said that we hear intent. We here is the place where we do intent block. We put a space. We put four spaces. We'll count it out. Uh, I'll count it. So one, two, three, four. This will also work, and so does a single tab. That will also work. You cannot use a space and a tab because that means it will be more than five spaces. So even though it will work here, it won't work here. See, guys, it's not working here. As you can see now, we have another enter password. Here, because I have autocorrect on, it already corrected itself to a single one. Because the moment we put another space, which I put now because I went against my autocorrect, it's saying keyboard interrupt past the interval. This is where the problem occurred. It's saying that it's not gonna say. We have to find it ourselves. That hey, the first one is wrong. There's something wrong. Both works. So that's one big problem that many of the people will face. It is uh, and many this was actually the only problem in old IDs. In new IDs, even if we have multiple spaces, it usually does work with the small, for example, the newest VS Code. It works with extra space and all. It works, not a problem for that. But to keep the code uniform, understandable, and easy, it is usually recommended that you use a single tab space or four space bars. The space bar key times. So like that's what should be in the space, rather than putting extra or less, something like that. It can always be great, it should not be less. So the third type of error we are going to face is using a single equal to instead of double. In the places where we need comparison with just like how we did for the password example, we needed to compare with a string for Python. So for that, we need double equal to, just like here. This is a comparison. Comparison is double equal to, not a single one. That's one of the biggest common errors that we face. So these three are the one of the biggest three common errors that we face. It is very much needed to be understood and rectified. This is why I tell you to memorize the don't memorize code, memorize, not understand the context and understand the logic rather than. So the next one is to predict the output. So we are going to guess the output. I want you all to write the code after we predict the output and validate output. And if in the case that we are all not able to do it, we'll do it ourselves. So prediction, guess, output. First one, x is equal to 10. X greater than 5, print A, if else print B. So X is already given as 10. What is going to be output here? So X greater than 5. So if the X the value is greater than 5, we should print A. And if it's not, which is else, it will print B. So here the X is greater than 5 because it's 10. So it will print A. So I'll give you some time to do it in your IDE and tell me what's the outcome and validate our outcome. So your time starts now. In the case if you're not able to do it, we will do it. I want, I'll make it a little bit more different. I want you to get the value as X. I want X to be an input rather than uh, an X, and I want you to all to give the input as 10. So take X variable as an input, and I want the variable that and the value you put in that as 10, and the input should be an integer input, right? So don't forget. Alright, guys, this much time must be enough. So let's do it. I'm gonna take X as integer input. One also. That should work. Close terminal. Let's do it again. I put X, 6, A. So we predicted that it would be A. I gave input 6, but the original person had input 10, so that would also result in A. In the case that input is less than 5, for example, we did 4, this will be. Now we are back to exercises. So we are going to check adult or minor. We have already done this in our previous example. So it's time for you to all to do it. In the case that you are not able to do it, we together and we'll validate the code. And yes, so your time starts now. I want the integer input. Okay, if whatever the variable you're creating, I want it as an integer input where we can check the numbers and stuff, right? So that's what I want you all to do. We should use both if and else. That must be enough time. This is the answer to the question. Uh, so we will do it. I've already done it for a long time, but we'll do it. My bad. Sorry, guys. All right, guys. I will. I'll end this terminal. I'll start a new one freshly. At the age, I'm 20. So I am an adult. Going to the next question. We are going to check positive or negative. This is easy. You have to use your brain and your logic. This is basically the same for what we did in the first exercise. Your time starts now. In the case you are not able to do it, uh, we will do it together. I want the input to be an integer input, so don't forget that. Time is up. This is the solution, and this is the solution. You can check. Let's do it. For the people who are not able to do it, we'll do it. I'll take on age. I'll take as number, and the number number is available. If it is under equal to less than 0, I will give it. We'll do something else too, guys. So we'll do something more, which is elif condition. If the number input is 0, what will we do? So I guess that was not accounted here. It's saying greater or equal to 0, we are going to positive. We're going to print positive. But if what 0 is neither positive nor negative. So we are going to do that. So if number is greater than 0, we're going to print positive. We're going to have an elif function. Elif number is equal to 0. We have an indentation. Print comparison, by the way. We need 2. there, not assigning. We need two equal to there because we are doing that. So that's mistake number two that we saw, right? Mistake number two or three in the common errors section we saw. Else, for that we're gonna call it negative. I'll just close this terminal so it is much easier. Perfect start. Asking for enter number, I'll print zero. So it says zero. Hey guys, it's alright. If your code looks like this, it's completely alright. I was just uh, doing, an extra mile to check zero because I felt it was necessary because zero, it is wrong to show that the zero is less than or equal. Zero as a positive number because zero is not a positive because zero is neither positive or a negative number. So exercise 3 is pass or fail. Uh, it is very easy. We have already done it countless times. I'll give you some time to do it, but we are not going to do it. We have already done it a lot of times. So your time starts now. The time is also going to be very less. I want you to take the input as a string and capital pass. Uh, so we'll compare it like that. Guys, time's up. This is the solution. We are taking integer out. Oh, we're taking integer output, right? Oh, I forgot. I'm sorry, guys. We have done it. You can always copy the code down. Note I did a small wrong thing there. I was taking as an input. I kind of misunderstood the question, guys. So I'm sorry, my fault. But I'll give you some time to copy down the question too. So yeah, the answer to the question, I'll give you some time. I'm sorry, my bad. I went to into the comparison part. That's it. Alright, guys, I believe this much time is enough. So let's go to exercise 4. This is quite interesting. We are looking at what is a largest of number 2. Largest number of 2. This is an exercise which I believe will take into account of all the knowledge we have done acquired till now in this course, especially the variable course. So it is taking multiple variable, multiple inputs, and then doing if clause, if and else clause in it. So it is quite easy. Use your brain, guys. I'll give some time. I'll give you more time for this. Your time starts now. I'll explain the code. I know the code. I'll explain the code. You have to take two integer out input, and you have to say something, and you have to compare them using if and else clause. So basically, that's it. Use the variable a and b or any other variable as you wish, but it just have to justify this outcome. Largest of two. That's it. I said this is enough time. We will stop. We'll check the answer. This is how I intended to use. So let's do the question. For people who are not able to do it, so let's do it. I'm gonna take a as integer input, and First the number. I'll take B as another input. If A is greater than B, then mm, bigger than D, else then B is bigger than A. Turn on next. With the first number 18, second number 20. B is bigger than A. I'll change it. I'll do something. Oh, no, 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 no. I'll do something. I'm gonna first do A. I'll do not the second one at B. So now this must be a little bit unique number. It will be A. I'm gonna say 20. I'm gonna say 80. So A is bigger than B. So guys, this is good. So we just check which is bigger. Right, if we just check which is bigger, we get different. Or it can be different. I did it in a different way. They did it in a different way. Uh, so I just wanted to show it in a grammatical way. It's in a very crude way. So the second exercise, the last exercise, is gonna be even or odd. If you remember what we studied in the previous lectures, and we use something in modulus, we learned that when you divide a digit with 2 and the remainder, if it is 0 or 2, it is an odd number, and if the remainder is 1, it is an even number. Sorry, it is sorry. I messed up, guys. So if the remainder that you will get after dividing by 2, it is 0 or 2, it is an even number, and if the remainder you get is 1, it is an odd number. So how do you find remainder? We use modulus function. Modulus function gives an integer value. So I want you all to do it. You know what? I want you all to do the code with your knowledge. I know this is quite hard. You might not be able to do it. So after giving some time, we'll do it together. So your time starts now. But time is enough. We are going to reveal the code. So here we have it. We'll do it. I know them now. So it's much visible for you guys. First type odd number. Oops. I used a different variable. My bad. And number 20, even. Yes. So guys, we have got that out too. So now we are back to my very big challenge. Not a big challenge, we call it mini challenge, which is a very interesting part that I include in my course. So we are going to do a student grading system. We have already done it. So I want you all, come on guys, you can do it in the time, your time. It starts now. It must be very easy, guys. Especially considering that we have, already done it. It must be easy for you. This example was used multiple times, right? So guys, you just have to take an input of number. I have to make your own guess. I will not tell you the great detail of what are the grading system is. You can put the grade. So you can, if you want to have some fun, you can put if you score 90, you have a fail. If you score zero, you are you are A student or something like that. You can play fun. You can have some fun also with little things like that. So see, that's the thing. I want to encourage you guys to do code, and if it's fun, it's not a problem. This is how you have fun. This is how you can have fun in with programming. So I want you all to do that too. Don't feel any shame. You can do anything, but it should work. The logic, the way of you doing it, it should be if else if, or if else using those clauses. So yeah, just remember that. I guess this much is enough. So really, I will upload. Yes, the else part is not shown. Uh, Sorry for that. But yeah, we have done it a lot of times, guys. We have also gone a little bit fancy. We have put name, but I don't know if it's not there. It will pass for me. It will pass because it was not completely said in the question. You can do this in your real life also. If something is not mentioned, and if you are not, if the answer is not like that, you can always say, "Hey, it was never mentioned, so how am I supposed to use it?" So it's a real life hack also. You can use that. Now we go to debug challenge where we find the mistakes. So the first code is this one. I want you all to write in your computer. Before that, uh, do the we will do some analysis. After that, you should tell me the one. So first line is correct. Second line is correct. I'll give a hint. Third line is where there is a mistake. I want you can always use a computer to check, but before that, you can always check in your brain. I'll give you some time to figure it out. I guess this much time must be enough. Uh, the mistake here is that the print function after the if is not indented. It's dynamic beneath if, which it should not be. It should be indented. It should have a tab space here. It doesn't have it. So that's a problem. So this is it. We are come to the end of this lecture. We have studied. We'll do a quick summary of this lecture. We have gone through if, we have gone through else, how and where it's used. We have gone through elif. We are going to nested if. We are going to logical operators as a recap, as a let's just say revision. We already learned it, and we did some exercises and exercises too. We also did a mini challenge. Once again, remember if is a comparison clause, it's a demand clause. Else is the last option. You don't have to put any sort of conditions here. LF is the second condition. After if you have to put another condition, it's LF. LF, there can be infinite number of conditions. There can be infinite number LFs that can be used. If you need a condition inside a condition, if you need to satisfy two conditions inside a condition, you use nested if. Nested if is an if clause lies inside an if clause. We have logical operators like assigning values and equal to values, something else, stuff like that too. And we also did exercises. This is a quick recap. This is a quick summary. Thank you for staying in this lecture. We will meet you in the next lecture. Till then, take care. Goodbye. Yes, let's go.